Hello guys, yeah. So this is the question 7 of the 2023, I meant to say, June. That was written on the 9th of June in Gauteng. And then, yeah, let's go. So in this case, they say, question 7 says, the graph of the cubic function f has a turning point at A and B, right? So at A and B, they've given us the x coordinates, right, of those turning points. And then it says the function f has the following properties. So let's analyze what they're telling us here. It tells us here that f prime, remember that guys, that f prime of x, right, this is the same thing as the gradient, right, of f, right? A derivative is a gradient, right? So by understanding that, it tells us that the gradient is greater than 0, right? The gradient is greater than 0, which means that this graph is increasing, right, when x is less than -1 and when x is greater than 2, right? So that's the first point. And then they tell us that f of x is, f prime of x is less than 0, which means the gradient is negative in between -1 and 2, right? So, okay, it's fine. So this is what they tell us. So I just want to, just visualize this, right? And the last point is that they tell us that f of 2 is greater than 2. So which means that where x is 2 on this cubic function, its y value is greater than 2, right? So yeah, we'll just have a look into that. All right, so let's go. So 7.1 wants us to draw a neat sketch of f, clearly labeling the points A and B on the sketch, and it is not necessary to show the x-intercept and the y-intercept, right? So it's okay. Let's go. So we just want to draw our axes here. So let's use this color here. So let's just draw our axes like that and something like that, right? So we have our axes there. And then now let's just, label, just put the point. So we have where x is -1. So let's just say this is -1. And then we have where x is 2. So we're just labeling. So let's just say this is 2 here. X is 2, right? So I'm just going to draw dotted lines all the way like that. It will help us. And dotted line all the way like that, right? Right, and lastly, we have where the f graph, right? So what this means is that the f graph, right, this cubic function that we're talking about, where x is 2, and where x is 2, remember, guys, it's also the turning point at B. So they see the turning point, right? The y value of the turning point is greater than 2. So let's go to our graph here. Let's say this is 2 here. It means wherever this graph is turning, right, its turning point where x is 2 is above this point where y is equal to 2, right? So it's fine. Let's check it out. And yeah, so let's go. So we have this, right, guys? So let's just study what they're telling us here. They say that the graph, right, the gradient of the graph is greater than 0 for where x, right, is less than -1. So it's to this side, right? And also where x is greater than 2, which means it's to that side of that dotted line that we've just drawn here, right? So it means that's where the graph is increasing. So what we'd see, right, about the gradient of our graph increasing, right? What we'd actually see is the graph going up like that. So this is what they're telling us. So we can just do this in the meantime, right? Because this is what they're telling us. So we can just put those lines just as a sketch. You understand that it's increasing, right? The graph is strictly increasing, right? Where x is less than -1 and where x is greater than 2, right? So that's the first part of our drawing. So this is what we have. And then they tell us that it is decreasing. The gradient is less than 0. The gradient is what? Is negative for x is in between -1 and 2, right? So this is -1 here and this is 2. They tell us that what? That our graph is decreasing like that. So in an essence, we're going to have a graph that's like this. You understand? Where this is -1 and this is 2. Because they tell us that between -1 and 2, our graph is sloped down, right? Which means that it's decreasing. The gradient is negative. It's going down, right? And then they tell us that where x is less, right, than -1, all the way that way, it's increasing, right? So as we can see, it's coming up. And then where x is greater than 2, of course, that's where they say it's increasing again, right? And it makes sense, right? So let's go. Let's try and draw a graph, right? And also one thing to note is that our turning point where x is equal to 2, can you see that? The y value of the turning point has to be above this point where y is equal to 2, right? So that's one thing to take note, right? Let's draw a graph, right? Right, so let's draw a graph. So just want to quickly extend this there, and then yeah, let's go. So our graph in an essence will look something like this. Just use a different color. Looks something like this, right? So that's the turning point, and then the graph will come and have another turning point here. So the graph will go all the way that way, right? And it is important to make sure that your turning point right here, your turning point here, right, is above this point where y is equal to 2, because that's what they told us there. They say that f of 2, right, it means that in our cubic function, if we replace the value of x, which happens to be the value of the turning point, which is 2 there, right, we have to get a y value that is greater than 2. So we have y is equal to 2 there, and then just make sure that your turning point is above that point. So this is our graph, and it just said label your turning points. So let's label our turning points, and this one is A, and this is B, right? So we have that there, right? So yeah, we cool, right? So yeah, that's it for that one, and then let's go to the next one, right? So the next one asks us to say that if f of x is equals to x cubed, if f of x is equal to x cubed plus bx squared plus cx plus d, calculate the values of b and c, right? So first of all, guys, what information do we have on this graph? We have the x values of the turning point, right? Initially, right, what we understand is that at the turning point, the gradient is 0, right? So the derivative of this cubic function is 0 at the turning points. Are we together, right? So understanding that, we can therefore use those x values that were given of the turning points and derive some sort of simultaneous equation that can help us solve everything else, right? So let's go deeper, right? So yeah, right. So this is what we have there. So let's go. So let me just write that down as we have it there. They say f of x is equals to x cubed plus bx squared plus cx plus d, right? So look at this, guys, right? So now that's what we have there, right? So understanding that f prime x, which is the derivative, right? Let's just find the derivative first, which is going to be using the power rule, right? 3x squared plus 2bx plus c, right? So that's our derivative, right? And we understand, guys, that at the turning point, at the x values of the turning point, we get that our derivative is equal to 0, right? So let's say where x is equal to -1. Let's start with the first one, where x is equal to -1, right? F prime x is equal to 0, because that's the x value of the turning point. So now let's replace our x value. So this, we just replace this with 0. So it's going to be 0 is equals to x into -1 squared, right, plus 2b into -1 plus c, right? And then now we can see that we only have two unknowns, which is our b and c, which hints to us that we're going to be using some sort of simultaneous equation, right? But that's okay. So let's push. So we have here, we have this, that. It's just going to give us 3 here, right? And then this is going to give us minus 2b plus c, right? So it means, just want to make sure that I isolate c alone. So c is going to be equals to what? 2b minus 3. Just took that to the other side. So let this be our equation 1, right? So now we have another piece of information. So look at this, guys. We have two unknown variables, which is b and c, which is what they're looking for. And also we have two sets of information. We have two sets of information that we can use, right, in order to make this a simultaneous equation. So let's move, right? So I'd like to just do this page setting. Let's go black, right? Black is beautiful, right? So yeah, let's push. So yeah, now that we have that there, right? So now that we have that there, let's push, right? So we also know that, remember we wrote that f prime of x, which is the derivative, right, was equal to 3x squared, I suppose, plus, let me just make sure, plus 2bx plus c, right? So that's what we have there. And yeah, so this is the derivative. But we also know that where x is equal to 2, right, which is the x value of the turning point, right, we know that also f prime of x is 0. The derivative of the graph is 0 because the graph is neither increasing nor decreasing, right? It's just at the turning point, right? But it's okay. So let's push, right? So let's go again. So we replace 0 here. 0 is equals to 3 into 2 squared plus 2 into 2b, I meant to say, into 2 plus c, right? So now let's go again. So we can see that this is going to be 4 times 3, which is 12, plus this 2 times 2 is just going to give us plus 4b plus c, right? So what I want to do again is either to replace c, because we have the value of c here, right? But I just want to make c subject to the formula again, right? So let's go again. So c, right, is equal to minus 4b minus 12. So now that we have established that both of these are equal to c, right? Just wanna, right? So this is our, let this be our equation 2. Right, so I made both of them equal to c. So if I'm equal to c and you're equal to c, it means we're equal to each other, right? So it's okay. So let's push. So therefore equation 1 is equals to equation 2, right? So let's go. Equation 1 was 2b minus 3. So c was 2b minus 3, right? And this is also equal to the other c, which is 4 minus 4b minus 12, right? So I take this 4b to the other side. It's going to be 6b is equals to that, to the other side is going to be equal to minus 9. So which means that b is equal to negative 9 over 6, which I believe is negative 3 over 2, right? So that's what we have there, right? We've got the value of b, but now we're looking for the value of c, right? So the value of c, remember we've written c is equal to 2b minus 3, right? Which is, I believe, equation 1. Let's just go make sure. Yes, this is the one, right? C is equal to 2b minus 3. So now that we have b, c is equals to what? 2 into negative 3 over 2 minus 3, right? All right, let me just go all the way back. And then, yeah, this is what we have. And then, yeah, so we can see that, okay, if we're to do this manually, this will cancel that. Therefore, we would have c is equals to minus 3 minus 3, right? Which means c is equals to minus 6. Yeah, so that's it. Sure. So yeah, if you want me to do the rest of the paper, just let me know in the comments, and then yeah.